In the previous lecture, we have studied about F-test. So let's now practice and solve some examples based on this test. So before moving on to solving this question, let me first revise all the things that we have done yesterday. So when do we use this F-test? Whenever we wanted to compare or test the variances of population here. So this is our aim. So for that, suppose we are given two population 1 and 2 having same variances, that is our assumption, and we assume that, so let me write down the assumptions. If we have two populations which are normally distributed and moreover the variances of these two they are same, then we draw two samples out of those populations having number n1 and n2 and variances as s1 square and s2 square. Now we wanted to compare these two variances. So what we do, we calculate the F statistics by using the relation s1 square divided by s2 square. So this would form your calculated F value. So the next thing would be, you wanted to compare this F calculated value with that of the tabulated value. So you require many things. So first of all, you should know what is your null hypothesis. So here obviously the null hypothesis would be the equality of two variances. Why? Because in this case we will only test the variances of the different samples. So here in the null hypothesis we formulate it like this: sigma 1 square is equal to sigma 2 square, and your alternative hypothesis, that could be any one of the three among these. So it could either be that we will say the variance of first sample is greater than the variance of second sample, or vice versa, or we would just say they are not equal to each other. So in the first two cases we say we have one tail test, and in the second case we have two tail test. So for the one tail test we compute whenever your sigma 1 is greater than sigma 2, you wanted to check that. In that case you calculate F to be s1 square by s2 square, the bigger quantity by the smaller quantity. Here also the bigger quantity is this variance, so bigger quantity divided by smaller quantity, smaller variance. And here also in this case we assume that the variance, this is the larger variance denoted by S capital M square, and we have smaller variance which is denoted by S small m square, right? So in this case we calculate the value of F like this. So always we write in the numerator the larger variance, and in the denominator we write this to be the smaller variance. And here for the degrees of freedom, whenever the sample size is n1, your degree of freedom is n1 minus 1. Whenever the sample size is n2, so it would be n2 minus 1. So here we would have 2 degrees of freedom. So for 2 degrees of freedom, now how will you test your hypothesis? For one tail test, we just have one portion of the distribution. So we will say this would be your critical region. So if you wanted, say, to check your hypothesis at 5% level of significance, then whole of this portion, whole of this area would constitute the 5% of the total 100% area, right? So we would say your critical value would correspond to this 5%. So that is represented by alpha here, which signifies the level of significance. In the first two cases, that is alpha only. So here for the tabulated value we use this thing, this number. This we will usually obtain from the statistical tables. So how do you obtain that? So you will take that F value corresponding to the given level of significance, where these are the degrees of freedom. So firstly you will write the degrees of freedom corresponding to the one having greater variance. So here you will write the degrees of freedom according to first sample, here you will write the degrees of freedom according to second sample. And similarly in this case the degrees of freedom would be written in the manner such that the variance is greater here. So sigma 2 square n2 minus 1, right, for second example. And similarly in the third case also, the degrees of freedom will be in the order that first of all you will write the degree of freedom corresponding to the larger variance and so on. However, in two-tailed test, what is the difference? We take alpha by 2. Why alpha by 2? Because here for two-tail, your critical region now divides into two portions. So that means the combined shaded portion should result in the given significance level, say 5%. So one portion would be 2.5%, another portion would be 2.5%. So that when you combine them, that would result into 5% level of significance. So you will check your tabulated value at alpha by 2 level, that is 2.5 in case of 5%, according to these degrees of freedom. So this is the F test. Now let's move on to solve this question. It says that it is desired to determine whether thickness of components manufactured by machine 1 has less variability than those measured by machine 2. Independent random samples, each of size 12, from two machines yield the standard deviation in the first case as 0.035 and in the second case as 0.062. So we need to test this variability. So this is required. So here for machine 1 and for machine 2, the two samples are available. So we have two samples corresponding to these two samples, each having size n. So your n1 is 12, your n2 is 12. So that means what would be the degree of freedom for first sample? It would be equal to 12 minus 1. So that would be 11, and in this case also your degree of freedom would be 12 minus 1, that would be 11. So these are the degrees of freedom for these two samples. For the first sample you have the value of standard deviation as 0.035, and for the second case you have the value of standard deviation as 0.062. This is also given to you. Now first of all, what we do, we'll write the null hypothesis. So here what is required to check, we wanted to check that is there any difference in the variability of the products manufactured by two machines. So that means we will check whether there is any difference between them or not. So in the null hypothesis, we always formulate the variances to be equal. So in this case, we say sigma 1 square would be equal to sigma 2 square. Why sigmas? Because we are comparing these for two machines using the two samples. So what would be the alternative hypothesis here? The alternative hypothesis here would be sigma 1 square less than sigma 2 square, because here what we wanted to do, we wanted to compare which machine is showing less variability. That means from the ideal product, how much variation is there in the product manufactured by machine 1 or the machine 2, right? So here this is the case. According to these hypotheses, next what we will do, we will compute our S. So the formula for S in this case would be, now you see which among these two is greater, whether your S1 is greater or your S2 is greater. So you see this S2 is greater here as compared to S1. So accordingly you will have the formula S2 square divided by S1 square. That means the variance of second machine divided by the variance of first machine. So accordingly your values would be 0.062 whole square divided by 0.035 whole square. So when you compute this, it would be 3.14. So this would be the calculated value for F. You may calculate this and verify whether you get the same result or not. Okay, next, after calculating this value of F, what you are to do, you are to check so this is your second step. In the third step, you are to check the tabulated F value. So here no level of significance is given to you. So we may check our results at say 5% level of significance. You may take any other of your choice. There is no issue. So for this, you have the degrees of freedom. So you are required to calculate the value of F at 1 minus 0.05 level of significance, having degrees of freedom. Now firstly, we'll write the degree of freedom of which one? The one which corresponds to larger variance, and that corresponds to S2. So we will write the degree of freedom corresponding to the second sample first, that is 11, and then for the first sample. So in this case, both of them are equal. So your numbers would just be 11 and 11. So for that, we will have to refer back to the table. Now these tables, whether most of the times are available to you very easily. So I have also written down the tables here. So here for 5% level of significance, that means we will refer to this table here. For 5% level of significance, our first degree of freedom is 11 and second degree of freedom is also 11. So for 11 degree of freedom, we will go and check for 11. 11 is somewhere between 10 and 12, right? And no explicit value is given to us. So that means we will take the average of these two values. That means 2.85 plus 2.79 divided by 2. So what would be that? 5.64 divided by 4. So that would be 2.82. So your tabulated value would be 2.82. So this is your tabulated value. So let's write that 2.82. Now in order to determine whether you will accept or reject the hypothesis, now in this case we are having one-sided tail. So here the tabulated value is 2.82, and what is the calculated value? Your calculated value 3.14 is higher than this value, and so therefore it will lie in this critical region. So if this lie in the critical region over here, so that means you will reject H0. If you reject H0, therefore you will accept the alternative hypothesis H1. So in this case, we will conclude that the components manufactured by machine 1 are less variable than those manufactured by machine 2. Right? So this is your conclusion here. And moreover, if you look carefully at these two sample standard deviations, so the standard deviation of first sample obtained from machine 1 is less than that of machine 2. So that is why we have formulated this hypothesis. Whether the same also holds for the populations as well. Okay, now moving on to the second problem. The second problem here is the one, it says that the following random samples are measured, are the measurements of heat producing capacity of specimens of coal from two mines. So these are the samples which you have from two different coal mines, and these are the values of heat producing capacity. So we are to test the equality of two variances at 2% level of significance. And it is given to you that the value of F at 2% level of significance with 4,5 degrees of freedom is 11.39. So that means in this case the tabulated value is already given to you in the question. Otherwise you may refer back to table. Now here you see we have different tables for different level of significance. So for 5% level of significance there is another table. For 1% level of significance there is another table, because you have 2 degrees of freedom. So here according to this we may also have table for 2% level of significance. We may refer to that if the value is not given to us. So for this example here, first of all what we do, we write our hypothesis. So in this case what could be your null hypothesis? Your null hypothesis would be would say that the variances, they are equal for both of the samples, against the alternative hypothesis which says that the variances in this case, they are not equal to each other, right? So for that, actually it is 1. Okay, now because we wanted to test the equality of two variances, so this is our null hypothesis and this is our alternative hypothesis, and because this is so, this is a two-tailed test. And for this two-tailed test, we wanted to check the equality of variances at 2% level of significance. So therefore for 2% level of significance, because this is two test, alpha is 0.02. So for this case, whenever your level of significance is equal to 2%, that means we will check here for alpha by 2. That means we will check at 1% level of significance. So that is why the value of 0.01 at 4,5 level of significance is given to us, 11.39. Okay. So for this value, we will test our hypothesis here. So in this case, because you are only given the raw data, so first of all you will calculate the mean and the variances. However, mean is not directly required. Mean and the variances. So in the first case, what is the variance? Variance for the first sample, that is given to be 15750. This we have already calculated in the previous question, previous test I guess. So you may check please this value. And the value for second sample, this is 10920. Now using two variances according to these two given data, in the first case how many data points are given to us? 5. So that means your degree of freedom in this case, n1 here is 5. So therefore degree of freedom would be n1 minus 1, that would be 4. So this is 4 here. And in the second case, because we have 6 data points, so therefore your n2 is equal to 6. So therefore degree of freedom here is equal to 6 minus 1, which is 5, right? So therefore this is 5 degrees of freedom here. So we will calculate the f value. What would be f value? The value of the statistics which is higher. So here you see this is higher. So we have S1 square divided by S2 square. So that would be 15750 divided by 10920, and it is equal to 1.44. So from here we obtain the calculated f value. Now if you move back and look at your test, now we wanted to compare the two values. So here we will check whether your calculated value is greater than this tabulated value or not. So in our case, if that is so, we reject our null hypothesis. So in this case, the calculated value f calculated, which is 1.44, is less than 11.39, which is the given value, which is the tabulated value at 4,5 degrees of freedom. Therefore in this case we do not reject null hypothesis, because according to condition it should be greater than this thing, right? So according to this, your tabulated value is somewhere here 11.39, right? And here your value is 1.44. So that means here in this case it is lying in the acceptance region. So according to that, we accept the null hypothesis, and according to null hypothesis we conclude that there is no difference between the variances of the two populations. So this is how we use F-test to determine the equality of two variances.